When I was writing up my dissertation work, I encountered some serious writer's block. Now, granted, I had a 12, a 10, a 4, and a 1-year-old at the time, so it's probably not all that surprising that I had trouble focusing, right? But daughter number 2, Elida, who was 10 at the time, wanted to help me out. And so she wrote up a list of things that she knew about the sun. And as you can see, she was a little bit worried about it touching her. Fair enough.
Wherever she is.
But this was a child who had seen lots of pictures of the sun on my computer in different colors and wavelengths, and so she perhaps knew a little bit more than the average 10 or 30-year-old. And she went on to write, "The sun has spots." Excellent. And the sun is a star. And this is the line that triggered me into writing again. If I go into any room and ask, what is the nearest star, about 99% of the time, someone is going to fire back at me with Alpha Centauri. I know some of you were thinking of it. It's like Free Bird. I know some of you were thinking about that too. But it's not. It's the sun. The sun is a star. Just like any one that you see at night in your favorite constellation, it's no different. And even more than that, it is the closest astronomical object to us. Most of us go through our days not even realizing that we are living with an astronomical object right next to us. And more than that, we're living in it, in its extended atmosphere, its wind, its weather, its tendrils. Sure, most of us are pretty familiar with the first part of her list. It's hot, it's bright, it causes sunburns, and we know that it does good things for us, like grow food with the photons that were created in its core a few million years ago, plus about 8 minutes of flight time. We all know that part, right? It is also the source of nearly every bit of energy in your body and in the whole solar system even. The sun brought you here today, and you thought it was your Lyft driver. Over 100 Earths would fit across its diameter, and it would take 1 million more to fill it up. And the embarrassing thing is, this star, the anchor of our solar system, which is everything to us, isn't special. It's actually pretty mediocre. If you were at any one of these stars in the Milky Way, looking back with your very own Hubble, you would not be able to distinguish our wee little system from the background noise. Sorry. Our sun will not even have the dignity to explode once it's done burning all of its fuel in its core in about 5 billion years. However, it will go out in a spectacular whimper and take all of the inner planets with it. And yes, you are sitting on an inner planet, such as life. Now, when I first embarked on my career in astrophysics, I wanted to study cosmology, the universe, big things, far away things, Hitchhiker's Guide to the Galaxy things, things that you needed a TARDIS to go see. I kind of tripped my way down into solar physics, and honestly, I was a little disappointed at first. The sun, after all, is only 93 million miles away. That is peanuts to space, honestly. I thought eclipses were as cool as it got. Now, don't get me wrong, eclipses like this one that went over Nashville just a couple of summers ago are incredible, and I cannot wait until 2024, and you better go ahead and book your hotel for it. But I thought that the sun was boring and flat, and that we knew everything we needed to know about it. It didn't touch me, and it probably didn't touch you before you walked into this room. Let's fix that, shall we? Here is a picture of a planet, Venus, the entire thing. You can even see the atmosphere around its rim. And in the background of this is something straight out of a science fiction movie. That star in the background is so massive that you can't even detect its curvature. And this is your next door neighbor. Now, if we zoom out a little bit and focus on its atmosphere instead of its surface, using more light than what our very limited eyes can detect, you can see this beast in its entirety and admire how gorgeous and complex it really is. And if we sit and stare at it for just a little while, what we find is that it is a superheated ball of plasma that is delicately dancing along writhing magnetic fields. It is constantly changing on all scales. And remember what I said, we're not just living with this beast, we're living in it, in its reach. So anything that happens at the sun can have profound consequences at Earth. And I'll let you in on a secret. Stuff happens at the sun. A lot. So remember those spots that were on Elida's list? Those are important. That is where the biggest explosions in the solar system occur. Sunspots are only dark because they're a little bit cooler than their surrounding material, but they would still melt rocks. They look completely static by eye, right? But if you zoom way in on them, they are ridiculously complex and dynamic. In this movie, at its highest resolution, you can pick out features that would fit between Nashville and Huntsville, 93 million miles away. So cool. I love my job. But what are these, though? Well, to answer that, you have to look outside of the visible spectrum. And what we find is that underneath, they are the locations of the sun's strongest concentration of magnetic fields. And above, they are regions of intensely hot activity, hotter than the surface. These are called active regions, and they are the source of hazardous space weather. And now we have finally arrived at the reason I'm really here, which is to give you nightmares about space weather. So, without further ado, let us begin with solar flares. You've probably heard of a solar flare, right? They are the highly energetic burst of light that can occur at these spots when the magnetic field gets so twisted and sheared that it pops, kind of like a rubber band, and then it instantly rearranges itself, kind of like magic, and it releases a ton of energy before settling back down again. Flare temperatures can reach into the tens of millions of degrees, which is hotter than the core of the sun where nuclear fusion is taking place. And yet, flares aren't what should keep you up at night. It is literally the mountain of ionized plasma that can be ejected with these flares. That is the real problem. These coronal mass ejections, or CMEs, can go roaring through interplanetary space at hundreds of miles per second. That is thousands of times faster than an F-18 jet. Now, the sun's activity cycles over about a dozen years. Right now, we are very near solar minimum, very near it. It's kind of boring. And we will ramp back up to solar maximum in about 2025, give or take, which just might coincide with our next trips to the moon. And I want you to remember that in just a second. At the peak of the cycle, CMEs are thrown out at a rate of about several per day. Some are bigger than others, and most of them are not aimed directly at us, because when they are, they can cause a bit of a mess at Earth. Fortunately, Earth has a strong deflector shield, much like the Starship Enterprise. Yeah, Star Trek fan. Called the magnetosphere, which protects us from these highly energetic particles. It redirects them towards the poles, and in so doing, energizes the aurora. Now, this consequence of a cataclysmic explosion in space right on your front porch isn't too shabby. Although it does take hundreds of tons of atmosphere along with it, it's okay, Earth can cope. But they're not all this gentle. In 1859, there was an event so huge, the biggest one ever recorded, in fact, and observed by eye, that it set telegraph poles on fire due to the tremendous induced currents at the ground. Now, when you look up what a telegraph is, what you'll find is that 160 years ago, we did not have a whole lot of technology compared to today. So that we were lucky that that was really the first or the worst of the damage that occurred. If that event had happened today, damages to the US alone could reach into the trillions of dollars. And that's because major US cities are sitting on top of nicely conducted bedrock. A more recent example occurred in 1989 when one of these space storms knocked out power to millions of people for 9 hours in Canada, costing the Canadian economy about $6 billion. $6 billion for 9 hours, and that was 30 years ago. And it's all because of these pesky charged particles that are moving at tremendous speeds towards the Earth. They can disrupt GPS, fry electronics, blow transformers, interfere with satellite communications, and that's just to name a few. And it's only going to get worse as we become more and more dependent on space technology, right? So no power, no internet, no social media, no GPS for planes near the poles. It's hard to pick out which one's worse. Now, I don't know about you, but when I'm flying to Japan for work, I find a degree of comfort in knowing that the pilots are not using the stars to navigate by. So I'm going to choose that one. And if we cannot protect equipment and humans, yes, that's me, and humans on the moon or on the way to and at Mars, then we may as well forget about deep space travel. In fact, there was an event that occurred in 1972 between 2 Apollo missions that could have killed all of the astronauts on the moon's surface in a fairly horrific way through radiation poisoning, even in their spacesuits. Now, remember what I said about possibly going back to the moon during the next solar maximum? Does that get your attention? Yeah, I hope so. By the way, NASA, if you're listening, I still totally go. I have my David Bowie playlist already picked out. I'm ready. Now, as bad as all that sounds, we're only mostly helpless. There are groups, or agencies across the globe that are working fairly tirelessly at trying to improve space weather predictions so that satellite industries and other industries can be prepared. As just one example, a NASA-led probe named Parker was just hurtled towards the sun this past summer. I was lucky enough to be at the launch. It was incredible. And it was sent out there to help us understand how the sun's wind connects the entire solar system, and also how the sun's temperature, or the atmosphere, is heated to temperatures that seem to defy physics. This is something that's been keeping us going for decades now. And on its way, on its journey, Parker will become the closest man-made object to a star ever. So, if Earth was out at Los Angeles and the sun was here in Nashville, Parker will get closer to Memphis. And there are many other groups across the country and across the globe that are working to find new ways of looking at the sun to fill in the missing pieces, because there are still many, like the group that I'm part of in Huntsville at Marshall Space Flight Center, where we develop instrumentation for testing on sounding rockets and on the International Space Station and on spacecraft. This one is going to launch again in less than a month, actually. This is an exciting time for solar physics. We're in this sweet spot where technology is finally starting to catch up to our questions. And I encourage students and your kids, come join us. This is a spectacular job, right? And you don't even have to be a scientist to do this. So please ask me how to get involved. There's a lot of job satisfaction that goes along with, I don't know, protecting the planet and enabling space flight. I feel like a superhero sometimes. Now, Elida, who is now in college, and where they listen to a lot of TED Talks, and she's one of my 4 favorite children. She's not my favorite. Wherever she is, she's out there. She put together a little presentation for me when she heard that I was doing this, because she was super excited, right? And it was titled Hot Knowledge, and it had lots of cool graphics in it, because that's what you learn in high school and college now. And here is her updated list of sun facts. And she has grown quite a bit over the past decade, and so has her understanding of our relationship with the sun, as I hope yours has as well in the past 15 minutes. The sun isn't just a big light bulb in the sky. It is where science fiction meets our reality. It is the best laboratory to the universe that we have, and it is just right there. It gives us a reason to look up every day and to work together for a very common cause, human survival and progress and all. And above all that, it is beautiful, and it's terrifying, and it touches us all. Thank you.